So, what are the laws of reflection specifically? So, these are the laws for regular reflection only, mostly because diffuse reflection doesn't necessarily same or have the same properties. So, this I'll just underline it that it's just for regular reflection. So, what are the laws? The angle of incidence is equal to the angle of reflection. So, angle alpha I equals alpha R, as we could see back here. The incoming one, if I just switch to a pen, this incoming one we label as alpha I, so angle of incidence, and the one coming out is the angle of reflection alpha R. Uh, we will also be using these exact ones for refraction, so the incident ray and the corresponding refracted ray. So that's where a bit of confusion could lie, but that's just how physics works sometimes. So the angle of incidence is equal to the angle of reflection. That's the first one. The second one is that the incident ray, corresponding reflected ray, and normal to the point of incidence are coplanar. Now, that is quite a loaded definition, so I'm going to go back to here and just show you properly. So I'm going to draw a 3D rendition. So here's a mirror, for instance, and then a light ray comes in, and a light ray comes out. There is what's known as a two-dimensional plane, which is like an infinitely thin um, like just essentially like a coordinate axis. We did discuss planes, I believe, when we did moments of inertia all that time ago. But simply put, it's literally just like a thin rectangle. So they all lie in some two-dimensional plane like vectors. Now, a normal to the point of incidence is if you a point at which the light ray actually hits. The normal to it is one that is perpendicular to that surface. So that's the incident. That's the reflection. And this is the normal at point of incidence. And as you can see, they're all coplanar, so they are all actually lying within this same infinitely thin two-dimensional plane. So, like I said, it always applies to regular reflection, but not necessarily to diffuse reflection because it acts a bit different.